Hey, welcome back. And we're going to be on week 31, the first week of May, May 3rd to the 7th. And we're talking about AP Stats in the SPV Math with Monte. Okay, so AP Stats, we don't have an actual team. Just click on SPV Math, and you can go to the stream channel to find any of the old videos. Let's go to the internet here. Internet, digital tools, Clever, Blackboard, AP Stats. Now, in AP Stats, these problems take time, as we've seen. So the last time we were together, I reminded you that each week we post some sort of a video with a couple of tutorials. But, no problem, math can be hard and AP Stats is time consuming, and I haven't taught that for years. So this past week I sent you a couple of cheat sheets. Hopefully you can see the formulas, and we need to make sure that we find the videos for the corresponding stuff that we're working on. Okay, so we did a really good job on the first module with random variables and the vocabulary, but we are spending our time on sample distributions. So this week, these calculations that we find, okay, and we're on sample means, okay, so let's just go back here to our overall. We went right through this the first couple weeks, and then the couple weeks ago we were on spring break, we worked on these. Last week I pushed to say, hey, in the month of May we got to get to Unit 7. But I thought today let's just spend some time on, I think it's question 8 here, and the actual calculation, because there's a lot going on. Okay, so in order to solve these, we're using these distribution curves and the normal. Again, take time and watch what it means to be normal based on sample size. Okay, and that's what the first couple of problems we're talking about, the definitions. These gentlemen do a pretty good job. Okay, a little bit of an echo in this gentleman's videos, but when we watch that, let's go through a help me solve. Okay, so in this case, we're talking about pregnancies and a standard deviation. All right, so as we walk through these calculations, we'll grab our calculator here, and what we got, 206 minus the 210, all divided by 11, and we're going to get negative 0.3636, so we can round that to negative 0.36. Check it. Now, what area should be determined for the 0.36? Okay, the area in the normal curve for less than, from 0 to 0.36 is what I think we're going to look for. Okay, we want everything else. So let's click on this first one. Okay, and we want this area over here, and we're going to go down to negative 3594. The probability area under the curve where z-scores satisfy the given inequality. Oh, to the left. Okay, cool. All right. So now we got to look at our curve, and we want this negative 0.36. Is that still open? No. Negative 0.36. Negative 0.36. 3594. 0.3594. 0.3594. Perfect. Okay, now that we're given that lasts at less than 206 days. 206 days. Therefore, the probability the 206, that's how we got this. So the probability that it'll last less than 206 days is 354. Okay, What is the probability a random sample of 13 pregnancies has a mean gestation of 206 days? Notice that the probability in this case for the mean sample of the population. This means that the sample size should be used, not the population distribution. And that's that whole vocabulary piece. Wow. Okay. So now we got to plug this stuff in. Okay. So the sample size n is drawn from the larger population with a mean u and a standard deviation of sigma. The sample distribution x bar will have a mean of x equal to mu, the standard deviation of the given formula below. Okay. So what is the mean sample distribution? I don't know. Okay? And I have no idea. Okay, and then we're going to have to ask for help. Remember that the larger sample size, the mean sample distribution, is equal to the mean of the population. So the mean of the population, 210. Okay, so 210. So now our sample size is 13. That's not going to be right. Remember, theta is the population standard deviation and n is the sample size. So what's our standard deviation? $11. Standard deviation was originally 11. Good. So now round to 6 decimal places. 11 divided by radical 13. 3.05085. 3.05085. 1, 2, 3, 4, 5, 6 decimal places. 051. Okay. Round to 2 decimal places. And to get to 2 decimal places, we have 206 minus the 210. All divided by 3.05081. 2 decimal places, negative 1.31, negative 1.31. Wow. Okay. So now negative 1.31. Negative 1.31. 0968. Use the table to the left. Find the area to the left. Negative 131. Negative 1.31. Sorry, 0951. 0951. Yeah. Okay. So, but we're in 9 minutes in this video, and we're not done. So we're definitely not looking for volume. Okay. We've got time, and there's a lot of note taking here. Okay, and it's all based on the difference between the whole population and the sample population. Okay, So 1.88648, 88648, 88648, 8. 1.88648, 6484. Yeah, wow. Okay, and again, more calculations. So what do we got? 4 divided by 1.88648, 212. Okay. No, what did I do? 88648, negative. Okay. Now we're going to go back to the curve. 212, 212, 170. Okay. Wow. 12-minute problem. Okay. All right. So let's see if we can get a couple of those done this week, and we'll call it good. Have a great week. AP Stats with Monte.